Okay, so suppose we're given a function f of x, and the function is just a list of points that belong to f of x. We might be asked something along the lines of find its inverse and state the domain and range of f and f inverse. Here's how we do that. Remember, finding the inverse just exchanges the domain and range. So essentially, every point's x value and y value will switch. So the y values of the point in the function will become the x values of the point in the inverse. So we can actually define f inverse quite easily by just reversing the order of the points. So we would have 1, 0, because these x and y switch. 3, negative 2, these ones. Negative 5, 5 from these, and negative 3, 4 from these. So actually it was rather easy to find f inverse. Now we have to state the domain and range of both. So for f's domain is the set of all points 0, negative 2, 5, and 4. We should list these in order. So negative 2, 0, 4, and 5. Now it's important to just list these specific points because f isn't defined for everything in between 0 and negative 2. It's only defined at 0 or negative 2. F's range is simply the list of all y values. So we have negative 3, 1, negative 5, and 3. So we'll start at negative 5, negative 3, 1, and 3. And now when we list the domain and range of f inverse, it should be pretty quick to see that the domain of f inverse is going to be the same as the range of f. Negative 5, negative 3, 1, and 3. And the range of f inverse is going to be the exact same as the domain of f. So we have negative 2, 0, 4, and 5. Now, to plot these, we'll just go ahead and plot it on an xy Cartesian plane that I've set up. So we have 0, 1. I'm going to plot the points from f first, so that point is plotted. I have negative 2, 3. I have 5, negative 5. And I have 4, negative 3. So those are the points that belong to f. Now we'll take a look at the points that belong to f inverse. I have 1, 0. I have 3, negative 2. I have negative 5 and 5. And I have negative 3 and 4. Now hopefully you can see the difference between these points. And what I'm going to do is I'm actually going to plot the line y equals x. And the reason why is it should be very clear that once the line y equals x is plotted, each of these points is a reflection of one point to another, and they're equidistant. So the distance here is the same as the distance here. And it's the same thing for all of these other matching points. So this green point and this black point, which were reflections of each other, are equidistant away from the y equals x line. Just like this black point and this green point. And so if those distances are the same, we know that we've appropriately graphed this. I caution you not to want to connect this with some sort of line. As I mentioned before, there are no points defined in any of these regions because of the fact that the function is not defined for all points. It's just defined for very specific ones.